Wild-type Neurospora can synthesize most of the chemicals that it needs for growth. It can grow on a minimal medium. Beadle and Tatum irradiated Neurospora with X-rays to increase the frequency of mutations. Later, they isolated spores and let them grow on a complete enriched medium. Spores from some of the resulting colonies wouldn't grow on a minimal medium, indicating that they couldn't make one of the compounds needed for growth. They were nutritional mutants. By testing growth of a mutant strain on media with different supplements, they could determine what compound wasn't being made. By this technique, they isolated 3 genetically distinct mutant strains, none of which could make the amino acid arginine. Biochemists of the day suspected that the related compounds citrulline and ornithine might be metabolic precursors of arginine. Therefore, Beadle and Tatum placed spores from each of the 3 mutant strains and the wild type on minimal medium with arginine, on minimal medium with citrulline, and on minimal medium with ornithine. The wild type grew on all the media. It doesn't need arginine. The mutant strains all grew when arginine was present. Strain 1 grew only when arginine was supplied. Strain 2 grew on either arginine or citrulline, but not on a medium with only ornithine. Can you figure out what this means? Strain 3 grew on either arginine, citrulline, or ornithine. What do you make of that? These results suggest that arginine is formed by a biosynthetic pathway leading through ornithine to citrulline to arginine. Beadle and Tatum presumed that every biochemical reaction requires a particular enzyme. Their results led them to propose that each mutation affected a different gene, each specifying a particular enzyme catalyzing a particular step in the pathway. They called this the one gene, one enzyme hypothesis.